All right, thank you everyone. So I'm from NASA Johnson Space Center in Houston, Texas, and I'm here to talk about Hermes. So I hope you're all paying attention because what I'm offering you is, I think, a very cost-effective way to send a 1, 2, or 3U CubeSat up to the International Space Station. So talk about, I'll give you some background for what this is, and I'll get into how it could benefit you. Okay, so I just want to start by saying get involved. So at the end of this, I'm going to give you my contact information. There is a deadline, so if you want to take advantage of this opportunity in the future, you need to respond now. So we want you. So we have an RFI, a request for information, out now, looking for ideas that will help inform the design of Hermes, which is exactly what that means. Okay, so Hermes in a nutshell. So it's being designed now. These are just some pictures of the experiment that it's based off of. But it'll be a microgravity experimental facility on the International Space Station, launching next year in 2018. So it's a reconfigurable experiment. What I mean by that is you can kind of see in these pictures there's different tubes. So there's 4 tubes in these pictures. So basically Hermes will have 4 reconfigurable sub-experiments or experimental volumes that can be replaced. And in the pictures it's tubes, but it's actually the size of a 3U CubeSat. So it can fit up to a 3U CubeSat. And again, 4 of these at a time. And this facility that's on the space station, basically you can take the 4 units out and put in new ones. So over time we'll have several different experiments. We'll have new experiments kind of waiting in line to replace the experiments that are out there. So the Hermes facility will have a robust electrical interface. So you have to meet certain standards to be able to fit into the facility, certain electrical standards. And it's open to any sort of investigation you're interested in. Anything that would benefit from the exposure to microgravity. And again, this is inside the space station. It's not outside, it's inside the space station. It will have crew members that can access it. So if you need a crew member, if you need, if it's not quite autonomous, but you want to test a component out, you can use the astronauts as resources. And then it's the power and the computation is provided by Hermes. So again, the idea of this is to facilitate science experiments, microgravity exposure testing, concept trials, any sort of idea you can come up with that fits within our design constraints, you can send up here. Okay, so what is this based off of? So Strata 1 is an experiment down at Johnson Space Center that just finished. So I'll tell you a little bit about Strata 1 and then bring it back to Hermes. This was an asteroid Regolith dynamics investigation on the ISS. So I see we have a lot of small body folks here, which is fantastic. So as you might know, the microgravity environment of the space station is perfect for studying small bodies and asteroids in particular. So that's exactly what we did. So we had 4 tubes, 4 clear polycarbonate tubes, each filled with different Regolith simulants of increasing complexity. And we trapped these materials at the beginning of the launch, sent them up to the space station. We had a device that pulled back and gave these materials room to move around. And we basically watched the movement of these particles over time. So it's really a Regolith dynamics investigation. So we had 1 year microgravity. We just finished the 1 year about 2 weeks ago. And again, we're trying to inform the models of Regolith dynamics. This is the first time something like this had been done for more than 30 seconds at a time on the parabolic flights. So Hermes is leveraging the success of Strata 1, as well as the design and the design team. But like I said, we're creating a facility. So Strata, we set up this one experiment that had 4 tubes, and then we're bringing it down, and that was it. Hermes is basically like Strata, except that you can replace these tubes over time. And again, it's not just tubes, now it's open to up to a 3U CubeSat or anything that will fit inside the volume that we're providing. And the last little there says it's a cost-effective and quick way to test CubeSats and CubeSat components. So what we get by being a facility on the International Space Station is the ability to send up new components for Hermes. So if you were to design a 3U CubeSat or any sort of experiment that would be one of the sub-experiments inside of Hermes, you have an avenue to get there, and that's one of the regular launches that go to the space station. So that would actually be included by being part of the Hermes team if you were to submit an idea. So basically a free launch in essence. So there's certainly some costs associated with building your hardware that would be on the user's end, and possibly some costs associated with making sure you meet our electrical interface standards and safety standards. That's all pretty minimal. By joining us is actually a way up to the space station. Okay, here's just a little bit more about Strata 1. So again, a lot of small body folks here, so you might be familiar with this. So the Regolith that we studied covers all airless bodies. So on large bodies like the Moon and Mercury, we understand that this evolution is dominated by impact processing. But on small bodies, there's all these other forces acting on it, and that's what we were trying to understand. And so any sort of future mission that goes to these bodies, you need to understand how to interact with this regolith, and whether that's anchored to the surface or using the resources there. So that's what we were interested in studying. And so the material that you see, is that representative of the whole body? We might not know. We don't quite know. I think there's another talk later too about orbital piles. There's a lot to be learned about asteroids. So again, this is just one example of what you can study with Hermes. It's really open to any sort of investigation. And this just has a little bit of information on the Strata 1 results. Our one-year mission is complete. We have all the imagery data returned. The tubes will be coming back so that we can analyze through 3D tomography where all the particles ended up. Not the strata. So back to Hermes. Okay, so the middle picture there, so that's about this big. This is called a locker volume. This is a standard volume used by the International Space Station. So the entire volume is about 17 inches by 10 inches by 20 inches. So within that space, you have the electrical box, which will be quite small, lighting, cameras, and then the 4 sub-experiments. So that leaves about 12 inches by 4 inches by 4 inches for each of the 4 experiments. So 3U CubeSat will fit in here. 2U, 1U, of course, and it doesn't have to be a CubeSat, I should say. If you have a component that maybe you're trying to get to fit into a CubeSat or to use on a future CubeSat investigation, as long as it meets our electrical interface standards and the volume standards, it doesn't have to be in any sort of shape. So there's certain things you have to consider, like how to mount the experiment to our structure. So we'll have ways in which we do that. The one thing to consider is, we'll have several experiments at once, so the astronauts will be coming in and taking their experiments in a way where we try not to disturb the other experiments in case they're vibration sensitive. And again, I've touched on this with the electrical requirements. So we're using something called MISSILE. It's modular integrated stackable layers. So it's basically a bunch of circuit boards that have these different electrical connections to them. And so we can very easily accommodate future investigations that might use different sort of electrical connections. Okay, so a little bit more on the CubeSat form factor, because I assume that's what most folks here are interested in doing. So again, this is a test bed. So you could test components if you have a component that's already a 1, 2, or 3 CubeSat, or could fit nicely into that size. If you wanted to evaluate the overall function of the CubeSat, say you have a 3 CubeSat that's ready to go, but you don't have a way to get it into microgravity to test it, this is a pretty good way to do that. And any sort of experiment that just uses that sort of volume. Okay, so the experiment, what do you get by being a part of Hermes? So you basically plug into Hermes, you remove your replace when you're complete. If your experiment takes hours, days, that's fine. If it takes months, even a year, that's fine. This Strata experiment was up there for a year. So it depends how much time you're looking for your investigation. We'll have lighting to provide it, and cameras, which can take imagery or video. And then the interesting thing is the software commands. So if you need your lights on the whole time, or you need them to come on every minute or so, or once, 1 minute every hour, whatever it is, the same with the camera, we can control that. So when you plug in your experiment, we'll be able to command the software from the ground to say, okay, for this experiment here, we want this cadence of lighting and imagery. So it's very customizable for new experiments. Okay, and this is just a slide on what Hermes can do for you. You'll see ESA astronaut Tim Peake installing Strata 1 last year. So this facility, because we're part of the space station, it has a lot of the capabilities there that you might need. So if you need to hook up to a vacuum port, there's different acceleration fields on different parts of the station, so we can actually move Hermes throughout the station if that's necessary. And that being said, we might get moved because of priority of other experiments on the International Space Station. So it will have an electronic interface wireless, so this just minimizes crew time. It has power distribution that's 28 volts. Again, activation of lights and cameras, but also other sensors. So we had, like I mentioned, a device that moved back and forth. Any device you can think of, again, as long as it meets our electrical standard. Downlink of data that can go right to you through NASA, but eventually to you. So you don't have to wait for your experiment to come back down. You can get it pretty quickly. And we'll have a front-end graphical user interface. So if the crew member does need to monitor something, go check on your experiment, they can do that. So we try to minimize the amount of crew time, astronaut time that is spent on experiments, but it's definitely possible. So if you have something that you're testing that's not quite autonomous, astronaut can come there and press a button or turn something on or off. Okay, so these are just some design questions that we're asking for users. So the good thing now, if you are interested in participating, is we're still in the design phase right now. So we're, like I said, launching in 2018, but still designing now. So if there's something I've said that just doesn't sound right, or that sounds like, oh, that'd be really great, except it doesn't do this, let me know. And that's the point of this request for information. So vacuum connectivity, perhaps, if that's something you definitely want or wouldn't want. The power, data rate, video versus imagery, something that I haven't thought of, then let me know. The express rack, that's the location that we're going, if that's acceptable, hopefully, because we're pretty committed to that part of the design, but again, this is the time to tell us. And if there's some sort of electrical interface that you know you definitely need, let us know and we'll make sure that's a part of our kind of standard electrical interface. As well as the volume requirements. And other things, you know, the micro G levels, acoustic levels, magnetic field strength, the orientation relative to the ISS vector, that was important for our experiment. So these are types of information we want from you. Okay, and this is just a real quick slide on what you can do with Hermes. So I call it Hermes A, B, C. That's kind of different versions of the sub-experiments that will go up. Because we're working with the Strata 1 team, we have a lot of asteroid regolith experts. So if we don't get ideas from other people, we're just going to continue doing asteroid regolith investigation, which is fine by me. So the next version of experiments that we have in mind involves similarly using asteroid regolith, but having more advanced components. So using a compression mechanism, having force sensors and penetrometers. Here's just a list of ideas that our team has come up with, that other folks have come up with, what you could do inside the tube. Hopefully you guys can come up with totally new ideas. Again, this could be a scientific investigation, testing out some sort of engineering component, some component that you already have working, you just need to make sure the mechanical joints work in microgravity, whatever it is, if you could benefit from microgravity, that's what we're offering. So this is just kind of a concept of operations and what's going on. But basically, you know, we construct Hermes on the ground, we launch it to the space station, we install it in an express rack. In our case, we have something called the entrapulator that moves to let the materials move around. You might have some other sort of actuation device or sensor that needs to be activated. And then the data can get downlinked back to you. And from that, you'll get some sort of imagery or videos or maybe some other sort of data. If you have a sensor that can gather other data. And at least from our experience, you know, we're getting some scientific results and complications from this. We hope that you guys could too by using our facility. And then at the end of this, you return the tubes. And again, not all 4 tubes have to go up and down at the same time. They can come and go, and we can replace them as needed. Okay, and here's just a list of the science team that developed Strata 1 and the design team, as well as the design team for Hermes. And you see at the very bottom there, it's you. So we hope that you will be involved. I hope that you'll reach out to me at the end of this and send me an email with your idea. So I'll end with this chart, your homework assignment. So you've got my email address there, kristen.k.john@nasa.gov. It says June 2nd, meant to update that. So we just got the deadline extended to Friday, June 16th to give you all more time. So maximum 5 pages. It could be a half page. You might have a component that's ready to go. Just write it up in an email to me in a Word document or directly in the email and say, hey, I've got this component. This is what we'd like to do. So there's no guarantee that you're going to necessarily get a spot on Hermes. But if you have any sort of suggestions for how to inform the design, we'd like to know. And so if you're interested, if anything I've said interests you, and you think one day in the future, years from now, you'd like to use Hermes' facility, you have to let me know now. That's the catch of all this, is we can get you pretty cheaply up to low Earth orbit, but you have to tell me now what your inputs are, and then you can kind of get on our list of collaborators to start using this facility. So, thank you. Appreciate it.
Thank you very much. Do you have any questions?
Hi, 2 questions quickly. One is, are there any restrictions on biologicals in terms of the experiments? And 2, is this directly through JSC or is it through cases?
No, this is through Johnson Space Center, through the ISS program, actually, so not just JSC, but the whole ISS program. It's possible that someone like Cases might take this over after a while, so we're designing it in our group at Johnson Space Center, but eventually it might, grow bigger than us, and then they might, something like that might take it over. As far as biologicals, it's absolutely allowed. So there's a certain safety process that obviously we have in place at NASA, so as long as you meet that process, so it might be something, you need certain levels of containment, for instance, so that's the one thing where the cost kind of depends on what you're doing. So if it's a very safe, easy to use component or experiment, there might be almost no cost involved to you. But if you have something that needs to go through the safety panel, that would be some time. That would probably be a visit to Houston to sit in front of the safety panel to say, hey, what we're doing is safe. But as long as you meet our safety standards, that's totally fine.
I was just wondering, the vacuum you mentioned, that's space vacuum or some artificial vacuum from some pumps?
Right, so just from the space station, we just have vacuum connectivity to vacuum just through pumps on the space station.
Okay, and which module of ISS is this going to be placed on?
So we've been in the US lab so far, but there have been talks of putting us in the GEM lab or some of these labs. So it depends, wherever there's room for us, for instance, and again, the orientation relative to the ISS vector, if that's important, then we can move maybe 90 degrees or something. But for now, we've been in the US lab.
Yeah, the reason I'm asking is that I was just thinking like for some radiation experiment, but the thing is that it will be heavily shielded as it is in the crew part of the ISS. So.
Sure. Yeah. So that's definitely something to consider. So if you had a strong desire to be somewhere else, that's something we could do. So we have all those connections. We've built all those relationships with the right people in the different space agencies to be able to move if we needed to. It would take time, but it's definitely something we could do.
So this is some sort of long-term program. There'll be more opportunities.
Absolutely, yes. It's definitely a long-term program, ideally, hopefully. So as long as we have customers that are wanting to use this facility, the idea is that this could stay on the space station, I hope, for indefinitely.
Any more questions? I guess not.
Thank you.
Kristen again.